Hi everyone, this is Dr. Nak. Today we're going to learn how to find the unknown values for the partial fraction decomposition. In our last video, we learned how to decompose a given rational expression into partial fractions. So today what we're going to do is we're actually going to learn how to find those unknown values such as a's and b's and c's. So I think the best way to do it by the example, so let's do it. Now, to find the unknown values, there are two methods to do it. Now, first one, I call it the smart zero method, and the second method is called the equating the coefficient method. If I were you, I will always start out with the smart zero method. Then if you still cannot find all the unknown values, then go with the equating the coefficient method. So yes, sometimes you're going to have to use both methods to solve for a's and b's and c's. Let's go with example 1, decompose the fraction into partial fractions. So part A, we're given negative 2x minus 9 all over x squared minus x minus 6. So step number 1, what you need to do is to determine whether this fraction is proper or improper. If it's improper, which means that the degree on the top is greater or equal to the degree on the bottom, if that's the case, then you're going to have to use your, the long divisions of polynomials. However, in this case, this is proper because degree on the top is 1 and then degree on the bottom is 2. So we're good to go. Step 2, factor the denominators out completely. So if I do that, then let me just factor this below. So please factor. So you're going to have x and an x. So plus minus. So it looks like you're going to have a 3 and a 2. Is that going to work? I think it does. All right, so let me rewrite. So our fraction now becomes negative 2x minus 9 over x plus 2 and then x minus 3. Okay, so let's first let's decompose this. So we're going to have two fractions. You're going to have a x plus 2 and then x minus 3. Now what goes on the top is the general form of the polynomial of 1 degree less than what you're given in the denominator. So this is going to be a constant, a's and b's. Okay, so from here you need to form a basic equation. Now what is that is this, you're going to have to linearize this expression or equation, I should say. So how do you do it is to multiply everything through by the LCD, which is x plus 2 and then x minus 3. So what I'm asking you to do is multiply this side by, I'm running out of room, x plus 2 and then x minus 3. And then you're going to do the same thing on this side, which is x plus 2 and then x minus 3. All right, so now notice that if I do that, then I can kill the denominators out. So what you're left with is just the numerator of your given fraction. So here what you're going to get is negative 2x minus 9 equals. Now what you need to do is just bring this LCD x plus 2, x minus 3 right next to a and cancel what you can. So what can I cancel? X plus 2 is going to cancel. So who's left over is just a times the x minus 3. Now you're going to do the same thing for b. Multiply this, put this right next to b and cancel what you can. Then x minus 3 is going to cancel out. So what you're left with is b and then x plus 2. Now this equation here is called the basic equation. So let me box that because this is a very important equation. Okay, let me write basic equation. Okay, now let's start out with the smart zero method. So what the heck is that? So basically what you need to do is find the zero of the denominator. So set x plus 2 equals to 0, then our x has to be negative 2. Set x minus 3 equals to 0, then our x has to be 3. So the smart zeros, let me just write. Smart zeros are x equals to negative 2 and then x equals to 3. Okay, so now what are we going to do with those? Well, we're going to plug that into a basic equation. So take one thing at a time. So let's go with when x equals to negative 2. So what we're going to do is we're going to plug it in negative 2 in place of x. Okay, now take a look at it. If x is negative 2, right? Do you see that this whole thing's going to disappear because I have a negative 2 plus 2, which becomes 0. 0 times b is 0. So this whole thing's going to disappear. So with that said, only survivor is going to be a. So we should be able to solve for a easily. But anyways, let me just work that out. So this is going to be negative 2 times negative 2 minus 9 equals a times negative 2 minus 3, and then plus b times 0. So I'm not going to even write that. So now this is going to be minus 5. Is that right? 4 minus 9? Yeah. Minus 5 equals negative 5a. So dividing by negative 5 on both sides, then our a is going to be positive 1. So we got ourselves an a. Now we still have other smart zeros, so let's do that. So now when x equals to 3, we're going to do the same thing. Plug that 3 in place of x, but notice that if I plugged it in 3 here, do you see that this whole term is going to disappear because this becomes 0. So here what you're going to get is negative 2 times 3 minus 9 equals b times 3 plus 2, which is going to give us negative 15 equals the 5b. Now divide that by 5 on both sides. So then what we're going to get is b is going to be negative 3. So let me box that. So we got a's and b's now, so we're done. So basically, let me just write down the answer here. Where in the heck can I write this? Okay, so basically this a is, we now know that this is going to be 1, and then this b is going to be negative 3. So here's our final answer. I could write it as negative 2x minus 9 all over x squared minus x minus 6 is going to be 1 over x plus 2 and then minus 3 over x minus 3. So that's going to be the final answer. So let me just box that. And here it is. So for this particular problem, we did not have to use the equating the coefficient method because by using the smart zero method, we're able to find all unknowns. Let's do another example. So we are given negative x cubed plus 4x squared minus 3 all over x squared times x squared minus 3. So first of all, this is a proper fraction because the degree on the bottom is going to become 4 and degree on the top is 3. So we're good to go. Now, we're going to have to factor out the denominators completely, but I believe that this has been factored out completely. All right, so now let's go with how many fractions are we going to have? Again, remember that depends on the exponent on the outside of each of the parentheses. Okay, so here you're going to have a 2 and a 1. So for sure, we're going to have 3 fractions. Okay, so let me bust that out. You're going to go 1 and then 2 and then 3. All right, now first one, you're going to have an x. And for under the second fraction, you're going to have the second copy of x, which is going to be x squared. And the last one is going to be x squared and then minus 3. All right, now what goes on the top is the general form of the polynomial of 1 degree less than degree 1. So that will be a. Now, yes, I know the next one looks like x squared, right? But you have to remember that this is the second copy of your x. So this guy is going to have the same exact form as your original copy. So here you're still going to have a constant, which is going to be just b. So be careful right there. That's the common mistake. A lot of students write bx plus c, but that's not true. So be careful there. Now, x squared minus 3, so 1 degree less will be first degree polynomial. So you're going to have cx and then plus d. All right, now the next step is this. We're going to multiply both sides by the LCD, which is x squared and then minus 3. So let me just write that out. Oh no, I'm running out of room again. So you're going to have x squared and then x squared minus 3. Now what you need to do is you're going to have to multiply that out. Now if I multiply this on this side, do you see that this denominator and this LCD is going to cancel out? That's exactly what we want. So we're just left with this, the numerator, which is negative x cubed plus 4x squared, and then minus 3 equals. Now do the same thing as what we did earlier. Bring the LCD right next to a and cancel what you can. So what can you cancel? Just one factor of x, right? So here, what you're going to get is a times x and then x squared minus 3. All right, now we're going to do the same thing. Now we're going to bring this LCD right next to b and cancel what you can. So what can I cancel? X squared. So here, what you're going to be left with is b and then x squared minus 3. Now the next one is going to be careful here. Cx plus d is one quantity. Put a parentheses around it. Cx plus d. And then notice that x squared minus 3 is going to cancel out. So what you're left with is just the x squared. So far so good. So we got ourselves a basic equation here. Now for this particular problem, I can already see that we're going to have to use the smart zero first, and then equating the coefficient because of this reason. Now if you want to find a smart zero, 0 of x is 0, 0 of x squared is also 0. Now x squared minus 3. Yes, if I set this equal to 0, then your x is going to be square root of 3. But who wants to deal with square root of 3 in here? Right? Unless you want to do it, that's fine. Okay, but I prefer not to deal with the square root. So I'm just going to leave this as is, and I'm not going to find the 0 of it. So here, in order for us to use the smart zero, we're good to go. Now, how do you do the equating the coefficient method? Well, what you need to do is you need to multiply everything out and then combine the like terms. Okay, so if I do that, then what we're going to get is ax cubed minus 3ax plus bx squared minus 3b, and then plus, now I'm going to distribute the x squared to each term, so you're going to have cx cubed plus dx squared. So far so good. So now what we're going to do is this. We want to combine the like terms, so into something of the form something something x cubed plus, and then now you combine the like terms on x squared, then combine the like terms on x, and then the constant. All right, so who has x cubed attached on it? Well, I see ax cubed and then plus cx cubed. So here you're gonna have a plus c, right? And then next one, let's go with the x squared. So who's got the x squared? I have bx squared and then plus dx squared. Is that it? Yep. So here you're going to have b plus d. All right. Now, when you do this, always try to separate each term by a plus sign. Okay, so that'll make your life a lot easier. Now let's combine all the terms with the x attached on it. So that will just be this guy, no? Negative 3ax. So this one, I'm just going to write it as negative 3a. And then the constant term is only minus 3b. All right. So now I think we're good to go. So in order for us to use the smart zero, so let's just get that one over with. So if I use the smart zero, what you need to do is we're going to do the same thing. Plug this into the basic equation. Remember, this is called the basic equation right here. And then we'll deal with the rest of it later on. Okay, so the smart zero in this case will only have x equals to 0. All right, so let's plug it in when x equals to 0. Plug this into the basic equation. So here you're going to have negative 0 cubed plus 4 times 0 squared minus 3 equals. Now, if x is 0, then do you see that this whole thing becomes 0, and this guy becomes 0 because your x is 0, so 0 times anything becomes 0. So the only survivor is going to be the middle term. Do you see that? But anyway, so let me just do that. So here, what you're going to get is, when this is 0, this whole thing is 0. And then you're going to have b times 0 squared minus 3. And then plus, now, if x is 0, then x squared is 0. So you got a x squared, 0 times cx plus d. This is going to be 0. So this is all we got. Okay, so then this implies that you're going to have minus 3 equals negative 3b. So that implies that b must equal to 1. So using the smart 0, we're only able to solve for b. Okay, so next step, what we need to do is we need to apply the equating the coefficient method. Equate the coefficient. Okay, so let's see what that's all about. So first of all, right, what's the coefficient on x cubed here? That will be negative 1, isn't it? Because this is negative 1 x cubed, right? Now, what is the coefficient on x cubed here? That's this whole quantity a plus c. That's the coefficient on x cubed on the right-hand side of the equation. But since these are equaling to each other, that means that coefficient on the left on x cubed must equal to the coefficient on x cubed on the right. So that should tell us that negative 1 better equal to a plus c. So that's what the equating the coefficients all about. So let me just go with this. So equating the coefficient on x cubed, what we're going to have is negative 1 equals to a plus c. All right. Now next what we're going to do is we're going to equate the coefficient on x squared. So where is x squared on the left? What's the coefficient on x squared? That's positive 4, right? Now let's go on the right hand side. Here's my x squared. What's the coefficient? This whole quantity, b plus d, right? So if I equate the coefficient on the left and the right on x squared, then positive 4 better equal to b plus d. All right, so that's what I'm going to write out. So here you're going to have 4 equals b plus d. All right, next, let's equate the coefficient on x. Now on this side, do we have x? No. So that means that the coefficient on x to the first, has to be 0 because there is no x to the first on the left-hand side of the equation. So, but on the right-hand side of the equation, what do we got? Coefficient on the x is negative 3a. So here you're going to have to set 0 equals negative 3a. Okay, so let me just write. So this means that 0 equals to negative 3a. Now let's equate the constant term. All right, so let me just write it as constant. Okay, now the constant term on the left-hand side of the equation is negative 3. Now the constant term on the right-hand side is just negative 3b. So here what we're going to do is we're going to equate the constant. Negative 3 equals to negative 3b. Now, we already know that b is 1, but from this last equation, if I divide it by negative 3, we can verify that, yes, b has to be 1. But we already discovered that. Okay, so now let's go with a then. Okay, so if I look at this, if I divide it by negative 3 on both sides, then a is going to become 0. Looking good. So we got our a's and b's. Okay, so now to get c, right? If you want to get c, then I would use the first equation. So we already know what the value of a is. This guy is 0. So that means that c better equal to negative 1. I'm going to write every step out. So that implies that you're going to have negative 1 equals 0 plus c. So c better be negative 1. All right, now let's go with d. So let's look at the equating the coefficient on x squared. So here we have 4 equals b plus d, but b is 1, right? So here what we're going to get is 4 equals 1 plus d. So if you're going to subtract 1 from both sides, then d is going to be 3. So what do we got? Do we have a, b, c, d? Is that all we need? I think so. Okay, so therefore we got ourselves an answer. So therefore, negative x cubed plus 4x squared minus 3, whole thing over x squared, and then x squared minus 3. This is going to equal to a over x, which is 0 over x, so this whole thing is going to become 0, and then plus b over x squared. So you're going to have 1 over x squared, and then plus c x plus d. So you're going to have negative 1x, sorry about that, negative 1x, and then plus d, which is 3. Now whole thing over x squared minus 3. Simplified a little bit, so this is going to equal to, so this is going to go to 0. So now you're going to have 1 over x squared. And then here you're going to have, you can leave it as plus minus x plus 3 all over x squared minus 3 if you want. Or you can write this as 1 over x squared and then minus x minus 3. Whole thing over x squared minus 3. It means the same thing. All right. But anyways, let me just box this guy for our final answer. All right, so let's do another one. So example C, 4x cubed plus 2x squared plus 8x plus 2 all over quantity 2x squared plus 3 squared. Okay, so first of all, how many fractions are we going to get? We're going to have 2, because remember, you count the exponent on the outside of the parentheses, right? So here we're going to have 2 fractions, 1 and a 2. Now what goes on the first fraction is the first copy of 2x squared plus 3. Now the next one, you're going to have 2x squared plus 3 and then squared. All right. Now what goes on the top is the general form of the polynomial of 1 degree less. So that will be a degree 1 polynomial because bottom is degree 2. So here you're going to have ax plus b. Now the second copy should have the same exact form. So you're going to have cx and then plus d. All right. Now, I don't know if you can see this already. Do you see that the smart zero method is not going to work? Because look, if I set this equaling to 0, right, you're going to have 2x squared equals to negative 3. So x squared is negative 3 over 2. Can x squared be negative? No. So there are no smart zero for this particular problem. So guess what? You're going to have to equate the coefficient. Okay, so, but anyway, so let me just multiply everything through by the LCD again to form the basic equation. So I'm going to take this and multiply here by 2x squared plus 3 squared. I'm going to do the same thing on this side. Yeah, we're always running out of room. Okay, so then what do we have? We're going to have 4x cubed plus 2x squared plus 8x plus 2. Okay, that's going to equal to, so again, bring this whole quantity right next to parentheses ax plus b and cancel what you can. So that means you can cancel out one factor of 2x squared plus 3. So here you're going to have parentheses ax plus b, and then another parentheses, right? You're going to have 2x squared and then plus 3. And then next one, you're going to have just cx plus d. All right, because the LCD and the bottom cancels each other out. All right, so now since there are no smart zeros, we're going to have to multiply everything out, and then we're going to have to equate the coefficient. So let's just multiply the right hand side of the equation. Okay, so what I'm doing is I'm going to multiply this out by foiling it. So here you're going to have, what the heck are we going to have? 2ax cubed and then plus 3ax and then plus 2bx squared plus 3b, and then just trace down cx and then plus d. All right, so now we're going to equate the, before you equate the coefficient, let's combine the like terms. So let's go with the x cubed. I think we only have one factor of x cubed, right? So you're going to have a 2a. And then now let's go with x squared. So x squared, we're going to have here plus 2bx squared. Oh, is that it? Alrighty then. So here you're going to have 2b and then x squared. Now let's go with all the x's. So we got 3ax and then plus cx. Did I do that right? Okay, sorry, I'm really tired right now. So here, what we're gonna get is coefficient on the x is gonna be 3a and then plus c, and the constant terms are going to be 3b plus d. All right, now we equate the coefficient. Okay, so now let's equate the coefficient on x cubed. Okay, so now let's look at x cubed, whose the coefficient on the left-hand side of the equation is 4. And who's the coefficient on x cubed on the right-hand side of the equation? 2a. So here, we're going to have 4 equals to 2a. All right, now let's keep going. Now let's equate the coefficient on x squared. So on the left-hand side of the equation, coefficient is positive 2. And on the right-hand side is 2b, right? So here we're going to equate it as 2 equals to 2b. Okay, now let's equate the coefficient on x. So here, coefficient on x is positive 8. And then on this side, coefficient on x is 3a plus c. So here we're going to write it as 8 equals 3a plus c. And now let's equate the constant. So the constant, okay, so the constant on the left-hand side, it will be positive 2. And constant term on the right-hand side is 3b plus d. So here, what we need to do is 2 equals to 3b plus d. All right, so now let's see what we can get. So let's go here. So if I divide it by 2, then we see that our a is going to be 2. Boom, that's nice. Now let's take a look at over here. Dividing by 2, then we can say that b is going to be 1. Okay, now to get c, since we know the value of a already, we can solve for c. So we're going to have 8 equals 3 times 2 and then plus c. So that means that you're going to have 8 equals 6 plus c. So our c is going to be 2. Looking good. Now let's go with our d. Okay, we can solve for d because we know the value of b. So here you're going to have 2 equals 3 times 1 and then plus d. So that implies that you're going to have 2 equals 3 plus d. So d is going to be negative 1. Is that all we need? A, B, C, D? Yup. Okay, so I don't want to write the original fraction. So is it okay if I go like this? So therefore, the answer is going to be ax plus b. So you're going to have ax and then plus b is 1 all over 2x squared plus 3. And then plus our c, what the heck is our c? 2x and then plus d. So you're going to have plus negative 1. So you're going to have a minus 1 all over 2x squared plus 3 squared. And we are done. How you all doing? Kind of getting the hang of it? I hope so. All right, hang in there. Let's just do one more. All right, so we got 3x cubed minus 12x squared plus 12x plus 9 all over x minus 3 whole quantity squared times x squared. Okay, so let's first find out how many fractions that we're going to get. So what are the outer exponents? We have a 2 and a 2. Add them together. We're going to have 4. Okay, so then I'm going to run out of room. So let me just go like this. Let me just bust out 1, 2, 3, and a 4. Now, what goes on the bottom is the first copy of x minus 3. Next one is x minus 3 squared. All right, now x has 2 copies. So here you're going to have a first copy of x and then second copy of x. All right, now let's go with what goes on the top. So the what goes on the top is 1 degree less than what you're given on the bottom. So this is going to be a. Now the second copy of x minus 3 better have the same exact form as the first copy. All right, now here you're going to have c, And remember, x squared is a second copy of your x. So here, I know you so want to say dx plus e, but that's not true. This is just going to be d. A, B, C, D. Is that right? Yeah. A, B, C, D, E, F. Yeah. So A, B, C, D. All right. I told you I'm really tired right now. Okay. So now next step, do the same thing. We're going to multiply by the LCD. So which is going to be x minus 3 squared times x squared. So we're going to do the same thing on this side. So let me just erase this equal sign and bring it over here. And then here I'm going to multiply here by x minus 3 squared times x squared. All right, so let's do this. So if I do that, then again, LCD and the denominator is going to cancel out. So what you're left with is just the numerator. So here you're just left with 3x cubed minus 12x squared plus 12x plus 9. That whole thing's going to equal to, now what we need to do is, again, we're going to bring this whole LCD right next to a and cancel what we can. So what can we cancel? 1 factor of x minus 3. So here what we're going to get is a times x minus 3 times x squared. All right, and then next one plus b. Now what cancels is on the next one, if I bring this right next to b, then x minus 3 squared is going to cancel out. So what you're left with is just bx squared. And then next one, do the same thing, plus c. Now the only thing that's going to get canceled is 1 factor of x, right, from x squared. So you're going to have x minus 3 squared times x. Oh no, I'm running out of room again. And then plus d. And what's going to cancel? You can cancel out the x squared. So you're going to have just x minus 3 whole thing squared. Oh boy. Okay. So now I'm not quite sure if we need to equate the coefficient or not. But this is our basic equation here. Okay. So let me just box this. And in case we need to equate the coefficient, let's multiply this out. Okay. So if I multiply this out, I mean, you can get the smart zero first if you want to, then multiply it out. But since we have an equation written right here, let's just multiply everything out real quick. So let me just bring this equal sign on this side. I have a feeling this is going to be a long equation here. So here you're going to have, first you're going to have, let me see, if I multiply the x squared, right, x squared into x minus 3, then do you see that right here? We're going to have a times x cubed minus 3x squared. Do you see that? All right, so then I'm going to multiply that through by a. So then you're going to have ax cubed and then minus 3ax squared. All right, and next one is just bx squared. And then next one, oh boy, now this is going to take a while. So now what we need to do is you need to compute cx times x minus 3 squared. So remember, x minus 3 squared is same thing as x minus 3 times another x minus 3. All right, so if I have to write every step out, so let me just write it as cx times x minus 3 times another x minus 3. So I just brought the x right next to c. Okay, that's all I did. Sorry, can you see that? Sorry, I put this x right next to c. I just reordered it. Okay, and then here you're going to have to multiply that out. And then you're going to have to do the same thing for the d. So you're going to have another x, d times x minus 3 and then x minus 3. We got this. All right, so I think this could be the worst case scenario, but we got this. All right, so now let me just rewrite. So you got ax cubed minus 3ax squared plus bx squared. Okay, now let's do this step by step. Now cx times, now I'm going to FOIL x minus 3 times x minus 3. Then you're going to have x squared minus 6x and then plus 9. All right, and then plus d times the same thing, right? Because that's another x minus 3 times x minus 3. So you're going to have x squared minus 6x plus 9. All right, now let's keep going. So now this is going to be ax cubed minus 3ax squared plus bx squared. And then now let's distribute cx to each term to get cx cubed minus 6cx squared plus 9cx. Now I'm going to distribute the d into that. So you're going to have plus dx squared minus 6dx plus 9d. Dear God. All right. Okay. So now I think everything's being multiplied out. So now let's combine the like term. So ready? So let's first go with x cubed. So how many x cubed do I have? Ax cubed plus cx cubed. Any other x cubed? Nope. So it looks like we're going to have a plus c times x cubed. All right, always separated by the plus sign. Now let's go with x squares. Okay, so what do we have? We have minus 3ax squared plus bx squared. And then minus 6cx squared. And then plus dx squared. Okay, so now let me just make sure that I'm doing this right. You're going to have negative 3a, right? And then plus bx squared. So you're going to have a plus b minus 6c and then plus d and then x squared. Oy, oy, oy. Okay, now let's go with the x's. So you're going to have plus 9cx minus 6dx, right? Is that all? Yep, because 9d is a constant. So here, what we're going to get is 9c minus 6d times x, and then plus the constant term is going to be just 9d. Phew. Okay, so now, since we have this equation now, let's first use the smart zero. Now, when you use your smart zero, you're going to put that into the basic equation. That's the quickest way to go. Okay, so let's first go with the smart zero. All right, so let's take a look at the zeros of the denominator. So here, the zeros of this is 3, and then x equals to 3, and then x equals to 0, right? So here you're going to have two smart zeros, which is x equals to 3, and then x equals to 0. All right, now I'm going to plug that into the basic equation. So let's take one thing at a time. When x equals to 3, now I'm going to plug that into the basic equation. So you're going to have 3 times 3 cubed minus 12 times 3 squared plus 12 times 3 plus 9. Now that whole thing's going to equal to, now again, notice that if I plug it in 3 in place of x, notice that this is going to go to 0, this is going to go to 0, and also this is going to go to 0. So the only survivor is going to be b, right? So here, this is going to equal to b, okay, so 3 squared times b. Is that right? Yep, I think that's right. So now let's compute this mess. Feel free to use your calculator on this, but I believe that the left-hand side is going to be 18 equals to 9b. Oh, that worked, right? And then so b is going to be 2. Okay, so we got one variable. Now let's go with the when x equals to 0. All right, so when x equals to 0, we're going to plug that into our basic equation. So when x is 0, then you're going to have a 0 minus 0 plus 0. So only survivor is going to be 9 on the left-hand side. Okay, and then this is all going to equal to, now when x is 0, then this is going to disappear. And this is going to disappear. And this is going to disappear, right? Because x is 0, then everything's going to be multiplied to that is going to be 0. So the only survivor is going to be the very last expression. So here, you're going to have 9 equals d times 0 minus 3 squared. All right, so that implies that we're going to have 9 equals negative 3 squared is 9d. So that implies that d equals to 1. So we got d and a b by using the smart zeros. but we still need a's and b's. Okay, so now next what we need to do is we need to equate the coefficient method. All right, so let me write down what we have so far. So remember what we did. I know it's such a long procedure. So what we did was we multiplied everything out on the right hand side of the equation, and that is gonna equal to this at the very bottom equation that we got. All right, so that means that 3x cubed minus 12x squared plus 12x plus 9 equals to this whole nasty expression. Okay, so I could copy that down on the next page, so hold on. All right, so what I did was I just copy and pasted what we had. All right, so here we have this nasty looking equation, but we already know that these 2 and these 1. All right, so here we're going to equate the coefficient now. All right, so let's first equate the coefficient on x cubed. Okay, so coefficient on x cubed on the left is 3. On the right is a plus c. So here you're going to have 3 equals a plus c. Because look, we only need to find a's and a and a c now, right? Okay, so keep that in mind. But anyways, let's just write everything out. So let's equate the coefficient on x squared. So the coefficient on x squared on the left is negative 12. And then the coefficient on the right hand side on the x squared is holy moly. So this whole thing. So you're going to have negative 3a plus b minus 6c plus d. Yikes. All right, now let's equate the coefficient on x. All right, so if I equate the coefficient on x, you're going to have 12 equals. Okay, so what is the coefficient on x on the right hand side? That will be 9c minus 6d. Alrighty, so now let's equate the constant term. Constant term on the left is 9 equals to, now it's going to be 9d. That should make sense because we already know that d is 1. But anyways, from here we know that d is 1, but we already have that. Now, from here you should be able to solve for c. Yay, look at this. All right, so now this implies that we're going to have 12 equals 9c minus 6 times d is 1. Right, so that implies that we're going to have 12 equals 9c minus 6. So add 6 on both sides, then you're going to have 18 equals to 9c. So dividing by 9 on both sides, c is going to be 2. All right, yay, looking good. So we got our c, b, d, so we need a. Oh, look, we can use the first equation, no? First equation is the simplest case. The first equation is 3 equals a plus c, but we just discovered c is 2. All right, so we got 3 equals a plus c, c is 2. So that implies that our a is going to be 1. Yes, was not as bad as we thought it's going to be. All right, so we got a's and b's and c's, right? A, B, C, D, right? Okay, good. So we got all 4. So now let's write down our answer. All right, so I just basically copy and pasted what we had before. So it looks like our answer is going to be A. So we're going to have 1 over x minus 3. And then plus B. So B is 2. So you're going to have 2 over x minus 3 squared. And then plus C is... Oh, C is 2. Hello. C is 2. So you're going to have 2 over x. And then plus D. D is 1. So you're going to have 1 over x squared. All right, so we are done. Oops. What am I doing? And there you have it. I think this one was a little bit brutal, the worst case scenario, but hey, we got it through, right? So I hope this gives you enough practice on how to find the unknown values for the partial fraction decomposition. And if you have any questions at all, please let me know, and good job everyone. Keep up the good work.